Hi everyone, Dr. P here again, and in this lecture we'll be looking at Chapter 19, Aldehydes and Ketones. This will be a short lecture with a nomenclature of aldehydes and ketones and a little bit of introduction to the carbonyl group. Alright, so aldehydes and ketones feature the carbonyl group. So that's a CO double bond. And an aldehyde has one carbon chain attached to the carbonyl and then a hydrogen attached to it as well. The ketone has two carbon chains. So that is the difference. We'll see that this makes aldehydes a little more reactive. Should mention that there are some special aldehydes here. If we've got hydrogens on both sides, this is formaldehyde. Now, I do want to talk a little bit about nomenclature. I know I haven't done too much nomenclature so far this semester because we haven't really introduced new functional groups. We did talk about aromatic compounds, the whole ortho-meta-para thing, but we were talking about dienes earlier, and you already know how to name alkenes. So anyway, here we are. So for nomenclature, if we have an aldehyde, we're going to use the suffix al. So this is where you need to be careful with your pronunciation and your writing. Make sure your A is, you pronounce it al, and it looks like an A, not an O, and don't pronounce it all, because that's an alcohol. So you want to make sure you're pronouncing this correctly. And then a ketone is going to have the suffix -one. Yes, it looks like the number 1, but it's pronounced -one. And in terms of numbering things, so for numbering carbon chains, maybe I'll just do it this way. So for aldehyde, start at carbonyl carbon, and then for ketones, we're going to start at the end closest to carbonyl carbon. Okay, we'll look at some examples in just a minute. And the only other thing to mention, is carbonyls as functional groups. And specifically, if we have a molecule with multiple functional groups, there's actually a hierarchy in terms of what you get the compound named after, which functional group gets to be the suffix. And so far, of all the molecules or all the functional groups we've looked at, aldehydes are actually going to get the preference. So if we have a ketone as a functional group, yes, aldehydes have preference over ketones. We're going to use oxo or keto as the prefix. And I'll go ahead and do a few examples just to sort of help you guys understand these. Before I get to some systematic nomenclature, let me just show you some common names. Okay, we have formaldehyde. Let's say C above. And then we've got acetaldehyde. And if we were going to actually name these using the IUPAC system, formaldehyde, well, it's the one carbon aldehyde. So that gets the root meth, and then the suffix al, or methan, for methane. So this is methanal. So formaldehyde would be methanal. Acetaldehyde would be ethanal. We have some other aldehydes, such as benzaldehyde. And then we have some ketones that we have common names for. The one you're probably most familiar with is acetone. And the IUPAC name for this would be propanone. But everyone just calls it acetone. And we could, if we had a benzene ring on one side of the ketone and a methyl group on the other side of the ketone, this would be acetophenone. If we had two benzene rings, that would be benzophenone. Some other older types of nomenclature involve naming the two alkyl groups. So acetone would be dimethyl ketone. You could have something like, we've got a methyl on one side, ethyl on the other side, and this is methyl ethyl ketone. But usually it's just called butanone or 2-butanone. There's really only one, because the way you number it, 1, 2, 3, 4, the carbonyl in butanone has to be on carbon 2. Anyway, that's an older system of naming things, and giving something a name like acetaldehyde, benzaldehyde, is also an older form. So if I had, like, let's say a 4-carbon, let's say I had this 1, 2, 3, 4. Okay, this used to be called butyraldehyde. But the IUPAC name is butanal. Okay, so just to give you an idea of some common names and some of the older nomenclature. So nowadays we just use the suffix al for aldehydes and one for ketones, and we name the whole carbon chain. In the olden days we would name the carbon chain but stick aldehyde on the end, or if it was a ketone, name the two chains on either side of the carbonyl carbon. Okay? The common names that you should know are formaldehyde, acetaldehyde, benzaldehyde, acetone, acetophenone, benzophenone. Yeah. All right, so let's do a few more examples of nomenclature. Okay. And let's see here. Let me just start drawing some, and I'll go go through them here. Let me do one more here. Well, maybe I'll do a couple more. Actually, I'll write them down here. All right, so let's take a look at these. Maybe I'll write in red here. So in this first one here, I have an aldehyde, so I'll start numbering at the carbonyl carbon, the aldehyde carbon. So 1, 2, 3, 4. And I have a methyl group on carbon 3, so this is 3-methyl butanal. All right. Now this next one here is a ketone, and I want to start numbering at the end closest to the carbonyl. So if I number from here, 1, 2, 3, 4. If I number from the other end, 1, 2, 3. So let's do that. 1, 2, 3, 4, 5, 6. So this is 2-methyl 3-hexanone, or 2-methyl hexan 3-one. Okay, either of those is okay. You know, I kind of learned more this way. This is a slightly newer, well, not slightly newer, but starting in the late 80s, early 90s, this became the usually preferred form. But anyway, all right, let's look at this next one here. Now, I have a cyclic system, so this is going to be some kind of cyclo something, but I also have an alkene. Now, where do I start numbering? Well, I'm going to start numbering at my carbonyl carbon. So that's 1, 2, 3, 4, 5, 6. So this will be 2-cyclohexenone. So notice I've got the 2, which indicates where the alkene starts, because it's understood that the ketone is carbon 1. So the 2 refers to where the alkene starts, and so I've got hexene, got the E there, and of course it's cyclo. You could also write it as cyclohexene. Phew, alrighty. Now, next one here, I've got 1, 2, 3, 4 carbons. So I just numbered that in the wrong way, didn't I? Let's scratch those out and do it right. Why did I do it wrong? Well, I got tricked up by my OH there. I want to number closest to, or the end closest to the carbonyl. So I should start numbering over here. So now this is 3-hydroxy, 3-hydroxy 2-butanone. The two may be a little redundant because we know that butanone, it has to have the ketone at carbon 2, because if it was at carbon 3, well, it wouldn't be butanone, or actually it wouldn't be carbon 3, but I'll let you play around with that if you want to. Anyway, last one here. I have an aldehyde and a ketone, so I want to start numbering from the aldehyde side. And as we introduce, or as we learn about more different types of functional groups, I will go over some of the hierarchy for naming things. Probably when we get to chapter 21, maybe, or 20, yeah, 21, chapters 20 and 21, and all the carboxylic acid derivatives. All right, so I've got 6 carbons. That's hex something. At carbon 5, I have my ketone, which is given the, or is called an oxo group. So 5-oxo hexanal, or 5-keto hexanal. So those are just a couple different ways you could identify the ketone there. I believe oxo is preferred. I'll often use keto because that's actually what biochemists do. Anyway, things like alpha ketoglutarate that tells you something where there's an additional ketone on your glutarate. Speaking of which, let's take a look at the last few minutes of this lecture here. Let's just take a look at the carbonyl group. So first of all, structure-wise, all right, so let's go ahead and I'll just put some functional groups on, not functional groups, some substituents there. One important thing to note here is that we have a polar bond. Okay, oxygen's much more electronegative than carbon, so we have a delta plus at the carbon and a delta minus at the oxygen. We could, if we wanted to, draw a resonance structure where we'll push our electrons up onto the oxygen. Why are we pushing them onto the oxygen? Well, it's more electronegative, so that's where they would go. And so now we can see in our resonance structure, we have, yes, positive charge on carbon, negative on oxygen. Now the carbon-oxygen bond is reasonably stable as well, so this resonance structure indicates some of the stability that we're looking at. But this structure gives us hints about the reactivity. Okay, this carbon is electrophilic. So that means that it could be a site for attack by a nucleophile. And there are a variety of different nucleophiles that could attack and add to an aldehyde or ketone, add to a carbonyl group. We'll talk about those in really all of the rest of the lectures for this chapter. We'll be just looking at adding different nucleophiles to the carbonyl group. Some exceptions, actually. I think maybe the next lecture I'll just do a little review of reactions we've seen involving carbonyls. One last thing I do want to mention is is another nomenclature numbering scheme. If I have a long chain, whether it's an aldehyde, ketone, whatever, I can use Greek letters to indicate my carbons. So I could call these, first carbon over is the alpha carbon, beta carbon, gamma carbon, delta carbon, etc. On this side I just have one, so that's an alpha carbon. So you'll actually see this. We'll refer to this terminology later on in future chapters. We'll look at reactions of carbonyls at the alpha carbon. And we'll look at alpha beta unsaturated carbonyls and things like that. All right, so just a little longer than I had wanted, but a short-ish video to introduce the nomenclature and a little bit about the structure of the carbonyl group. In the next video, we'll start looking at some reactions. All right, well, until next time, stay safe out there. Bye now.